The midrange is the average of the lowest and highest values in a data set. For the data set below, find the midrange. So the first thing I'll do is I'll identify the lowest entry and the highest. And according to the formula here, we just want to average those two. So add them up, and we'll divide by 2. The midrange is 42.5. An outlier is an unusual piece of data. It's an observation that lies abnormally far away from the usual observations. Which of the values in the dataset appear to be outliers? Well, I would say 65 appears to be an outlier. Seeing as how most of the entries here are in the 20 to 24 range, the 65 stands out as unusually far away from most entries. On the diagram below, we see 3 measures of central tendency, and I'll just add one more, the midrange. It occurs right here, 42.5. And what we'd like to do is see which of these measures of central tendency are highly affected by outliers. A measure of central tendency is a number which tells us about the middle of the data. So if you take a look here, the mode does not appear to be highly affected by the presence of the 65. Like, for example, the mode would be 20 no matter whether the 65 was 65 or something else. It wouldn't matter if the 65 was there or not. So what about the median? When we find a median, we cross off one at the bottom and one at the top, and then one at the bottom, one at the top, and eventually we work our way toward the middle of the data. So the fact that this number happens to be a 65, that doesn't really impact the median to a great extent. But check out the mean. The mean got pulled pretty far to the right here from where it would have been if the 65 wasn't there. So I'm going to say the mean is highly affected by the presence of an outlier, and certainly so is the midrange. And that means the mode and the median are not so affected.